I should turn off my. Is this working? Okay. Hello. Well, I don't know why I said hello like that. Anyway, today, or to wow, okay. I had a beautiful introduction in my first take, and now I'm bombing. But I'm gonna just go through a little crash course on finding the least common multiple using the cake method, which I showed you guys earlier, because we need to know how to do that quickly and effectively now. And it's nice to have like a surefire answer. So on this problem, we're gonna be trying to find the least common multiple of 4, 18, and 15. I hope you guys like my new pink. I think it's pretty. It's a nice little like shade. Anyway, let's just hop into it. So it's just like before, where um, I showed you at the end of the greatest common factor tutorial, like that we could end up using it to find the least common multiple, but we didn't care about that until now. So remember, we're gonna pull out a common factor to like pull out of it doesn't have to be all three of these. Notice 2 doesn't go into 15. And so what we're gonna getting on the next layer is just 2, 9, and then the 15 stays as it is because you can't do anything with that, which is totally fine. And now the goal is to eventually have all of these numbers be prime, right? And so 2 is already there. Yay! And now we're just gonna pull a 3 out. And that's gonna once again leave the 2 alone. And then now we're gonna have 3 and 5, and boom, we're done. This is our answer, believe it or not, because now we have 2 times 2 times 3 times 3 times 5. We just take all of the results here and we're gonna multiply them. Which this is like 2 squared technically times 3 squared times 5. This is the prime factorization that Dr. Webson loves all the time. And that gives us 4 times 9 times 5, which equals like 20 times 9 equals 180. 180 is our least common multiple. It's really nothing crazier than that. I have another example over here, and you can do these in any order. I typically like go left to right, but like we could pull out from these two since they share, or these two, or if like 5 and 36 did share something, we could do it there. But since I can easily see, I can just pull out a 5. I'm gonna get 1, 4, 36. And then now I'm gonna pull out a 4 and get 1, 1, and 9. And then we multiply 5 times 4 uh, times 9, because notice the 9 isn't prime, but like I could, I guess, go again and get 3, 3, 1, and 1. But we don't need to do that because we have ones here. That also just equals 180, like before. I just made this other example and it also has a least common multiple of 180, and I found that as a funny coincidence. But that is the entire method. That's all you need to do. Practice at it a few times, you'll get really good at it, where you just go, yep, yep, yep. But he mentioned something in lecture, which I found like a little like, huh, why does that work? As a kid, I was always fascinated by these problems. What is the least common multiple of 3 and 5? And it happens to equal 15, just like 3 times 5 equals 15. And I went, huh, why is it that sometimes the least common multiple is just the product of the two numbers, but other times, if I do the least common multiple of 2 and 4, as math majors, we can easily see that that's just going to be 4. But 2 times 4 equals 8. And it's like, why is it not true for this one? And I find as a like a math tutor, a lot of kids, I guess this is probably like a fifth grade level. I would say that they're definitely not in middle school. This is earlier. This is elementary stuff. They fall into this trap where they see 3 times 5 and they go, oh, I can just multiply them. And while multiplying them always gets you a multiple, it doesn't get you the least common multiple every time, especially with like 2 and 4 or a bunch of other examples. And as like math majors, we can see why this is. And he teased at this a little bit in like the most confusing way possible. Notice here what the GCD of 3 and 5 is. It's 1. They're relatively prime. But over here, the GCD of 2 and 4 is 2. They are not relatively prime. But if we take this formula up here, which he ends up writing this as m times n, the least common multiple, which down here is 15, times the GCD will always equal 3 times 5. It will equal the product. And same over here. The least common multiple is 4 times the GCD is 2. That'll always equal the product, 2 times 4, or 8. Isn't that interesting? This is just the way it works, and you can actually prove this since we're math majors. I won't do that in this video, I promise. But um, this is like a very cool trick of like, oh, if they're just relatively prime, like if I have find the LCM of 3, 4, and 5, I don't have to use the cake method here because they're all relatively prime. So I know that the LCM is just going to be 3 times 4 times 5, and that's 60. And I'm done. So a cool little trick. Obviously, if it's not, and I have like LCM of 3, 6, and 5, well, now I just have to find the GCD, which is 3. Wait, it's 3, I think. And the wait a second. What? Wait, why doesn't that work? 90 is the product. Oh, no, that does work. Yeah. Okay. And then I find the product, which is 90. And then, so that means that the least common multiple is 30 because 30 times 3 equals 90. Sorry for my hesitation there. I think that's pretty neat. And kind of like if you get good at this, then you don't need the cake method unless these numbers are like really big and very like difficult to interpret whether or not they're relatively prime or what their GCD is. But yeah, anyway.